I'm happy to talk a little bit about infrastructure. So most talks I've been attending so far were rather on the application side. So I'm happy to meet maybe already existing users or hopefully future users of the tools that I'm going to present now. So first, let's start with who in the audience has already been working with containers. Please raise your hand. Wow, so I'm done, right? Well, I didn't expect it to be so high, but I'm very, very happy. It's awesome. So short, very briefly, why are we using containers today? Well, at least in my opinion, it's an easy and cheap way to ship and deploy applications. There are countless use cases, but it all started with we can bundle the dependencies of an application along with the application. We don't have to worry about potential conflicts. Do I need to install the package, and am I facing dependency conflicts? Does it work on node A or on node B? Do I always have the same library that my tool requires on all deployments? Containers are also commonly used to achieve greater scalability compared to virtual machines or just using rsync or SAP and copying things around. And it somehow falls the paradigm of building our application once and running it everywhere. The benefit of doing that or following this paradigm is that we achieve portability. That's somehow the inherent part of running something everywhere or making it runnable. Also, reproducibility, which is especially important. Well, I'm working now for a Linux distributor, so reproducibility is always great when you want to ship packages and source code. And if users or also the distributor wants to recompile everything, it should always be the same output. But in a previous life, I was working in academia, and there a very common problem is reproducibility of results, right? When reading a paper, quite often the authors make the data or even the experiments public, but when you try to reproduce it, there are so many factors and interdependencies, and it depends so much on the environment where you execute it that reproducibility is still a big thing. Containers are not the ultimate solution, but they can be a good tool to achieve it. And certainly flexibility. If I can run my application on my workload potentially everywhere, I don't need to worry anymore where I need to run it. Also, there's really great tooling and support, and there's a huge, huge investment from the industry, which helps in making containers even more popular, right? If you're faced with a decision, shall we invest into containers or Kubernetes in general or not, then looking at who is already betting on it helps a lot. And basically all big companies are doing it. You can go through the stack. Amazon, Red Hat, Intel, Google, Microsoft. So if all these companies invest in it and bet on it, it reaches a certain confidence in following this bet. A very common comparison on how to explain containers are virtual machines. As most of you are already working with containers, I just briefly go into it. So when you look here on the left side, virtualization, we have a couple of applications running on guest operating systems. All of them are running on a hypervisor, which is then running on the host. There's quite a lot of redundancy. I hope all of you are using a Linux host and a Linux guest, and assuming there is some update we need to run. Well, even for the maintenance, from the maintenance perspective, we have to update all of the kernels, right? Besides the fact that all these kernels consume resources. So there's a lot of redundancy. They're still being used for various and valid good reasons, but containers are really more lightweight. As you can see on the right, we have one host operating system, and then the containers all sharing this host. In fact, they're just glorified processes on the Linux container or on the Linux host in general. So let's have a look at the life cycle of a container. What are common operations, common things and problems we face when working with containers? Well, first, we want to build a container, right? This means we somehow bundle or create an application. We put it into the container along with the dependencies. There's various tools to implement that. I'm also going to show one later. We can use so-called base images, such as using Fedora, Ubuntu, Debian, you name it, or even high-level base images which already ship with an Apache container, so we don't have to start from scratch all the time. And what is the next step? So I think once we build a container, we have to distribute it. By distributing, I mean we usually push it to a container registry. It can be Docker Hub, which is very, very popular. There's also CRI-O, which comes from CoreOS, which is now also part of Red Hat, or we just have one running on our local development machine, or in general on-premise in the company, university, or wherever we want to have it. Next, and most importantly, because we just don't do it to waste some energy, we want to run it or deploy it on a machine. Well, that's the ultimate goal, right? We want to run our application. And the last use case is orchestration. By orchestration, I'm talking about distributed systems, really provisioning, scheduling, taking care of redundancy, and in my point of view today, that's really Kubernetes. Kubernetes is the de facto flagship for container orchestration. All of the companies that I mentioned before are betting on Kubernetes. All of the companies ship their products, and they also use it in-house, which explains a certain confidence in the maturity of these tools. And especially Kubernetes is incredibly successful and fast-growing. And in fact, Kubernetes can be compared to the Linux kernel, with the amount of people and companies working on it, and how fast it's being developed, and also how fast it's being adapted all around the industry. So here comes finally the Swiss Army knife, the metaphor I'm using throughout the talk. So all of you will have heard Docker, right? Docker is the de facto term or company that started containers, at least made them very, very popular. And Docker can do all of these things that I mentioned before. So it's building, distributing, running, deploying. And there's also Docker Swarm, for instance, where it can orchestrate the containers across nodes. It's incredibly powerful and feature-rich, and it supports certainly all kinds of use cases. And the Army knife I'm showing here is somehow the metaphor I'm comparing Docker with, because you really have hundreds of use cases, a lot of features, and all of them in one tool, as you have with this Swiss Army knife. It's really a Swiss Army knife. You can actually buy this one. But in my opinion, it comes at a cost. So for instance, what about the non-functional properties? Is it lightweight? I argue not. Maybe somebody with bigger muscles than I have can cut an apple with it, but I will hurt myself if I try to cut an apple with it. Can I actually tame the testing matrix? Right, I have this one big tool, and I want to test it if it meets my requirements, if it fulfills the tests that I've written. If I change another feature, does it impact me? It's a really, really tough thing. The bigger it gets, the more complicated. So, or when it comes to the size of it, can I put it in my pocket, or do I always need a suitcase if I want to transport it? I'm small enough to put, or too small to put this in my pocket, so I certainly need a bigger bag. And in the end, is there some room left to add new things, a new feature? What if I have a special feature, I don't know, a water boiler? Can I add it there? Not really. Certainly nothing will work anymore, right? But if I just ship a water boiler instead of attaching it there, well, then it's way easier. And this is pretty much the philosophy that the tools that I'm going to present in this talk follow, and also Red Hat's containers philosophy behind, which is we try hard not to have one-size-fits-all solutions, because they come at the costs, or the costs that I just described before. So we want to have use case, dedicated, and specialized tools. And certainly Red Hat is an open source company. So we want to invest in open standards. Everything should be and is developed in the open. And this also implies open source licenses, open source development model, community-driven models, no CLAs and things like this. All these tools must be interoperable. So if I use a small knife to cut my apple, well, I should be able, I don't know, to put the apple afterwards in the pan that I want to cook it in, for instance. The reduced scope has certainly a lot of impacts on non-functional properties. The tools become smaller. It's easier to innovate because you don't have to worry about certain impacts or undesirable side effects on other things. The binary size is smaller, the attack surface is smaller, the security improves by that, at least from a non-functional perspective. But now let's get to the containers, or to the tools. So which tool do we have for building? It's called Buildah. And there's actually a very, very funny anecdote behind, because the big container architect at Red Hat, Dan Walsh, he lives in Boston, so he's a very strong Bostonian accent. And when he reached out to the team, and a couple of years ago, he said, well, now we got a couple of tools already for running, distributing, and orchestrating. So how about a tool for building a container? So let's just call it Buildah. So this is how it came to be, and also the Boston Terrier, the logo, somehow in due to the fact that Dan has a very strong Boston accent. But now to Buildah. Buildah's functionality goes beyond Dockerfiles. So there's many ways to build a container. When you Google for it, the first way to do it, you will see, will be a Dockerfile. Buildah supports Dockerfiles, but it's really meant to be used as a low-level core utils-like tool for building images. As much as we can use the core utils on Linux, BSD, yada yada, and build a bigger logic around CP, LS, and all these tools, cat, that grep, that we somehow take for granted, we imagine Buildah to be used exactly like this. It offers a certain amount and degree of flexibility, but it tries to be very unopinionated in the way containers should be built to really meet as many use cases as possible, and to allow for others, for more high-level tools to build around that to implement their functionality on whatever they need. And everything is developed in the open at github.com, containers, and then the Buildah project. So if you want to build a Dockerfile, you can use Buildah build using Dockerfile, or shorter for the lazy ones, which I always do, is Buildah bud. It runs rootless. Later, I'm going to talk a little bit longer about what it means to not require root access, which, for instance, Docker had for a long while, the security impacts of it. It also runs daemonless, so you don't have to start a daemon to build a container. It follows a very classical fork-exec model, so you can just execute it. You don't need to start a daemon and then have a client talking to it and running into all kinds of problems when trying to integrate a server-client model into an existing Linux system. It also exposes a Golang library. In fact, some of the other tools that one other tool I'm going to present later is making use of that already. And it's easy to integrate into Kubernetes pipelines, right? You just have to call a process. You don't need to start a daemon or go indirectly via systemd to start something as simple as just building a container. We also offer them as official container images. So if you have a Kubernetes system and you want to build container images in your system, you can use the image here, which is hosted on CRI-O, Buildah, stable. You can use this to implement your logic. A very common question is, well, does Buildah have another or a dedicated scripting language, perhaps Buildah file, because there is some needs to improve Dockerfile? And Dan Walsh keeps to joke, yes, it's called Bash. It's Buildah's scripting language. So whatever we have on the host, we can use to build our container. So here I want to run quickly, because time is scarce, through an example how we mean, or what we mean by that. So with the first line, Buildah from scratch, we create a new container. Can you still hear me? Yeah. We create a new container from, or scratch has a special meaning. It means we have no real base container image. We start from scratch. It's basically an empty one. Then when doing this, Buildah creates a so-called building container or working container, which is basically a process running, which has the rootfs of the image mounted. And we can use the building container to mount the root file system of it. Then we can operate on it. So in scratch mount is now we have the root file system of the container, and we can work with that. No Docker file needed for it. Really, if we want to add source code, we just do cp-r, our source directory, and then copy it to scratch mount. So what it allows is that you don't need to consider a container as being something special. We want it to be as boring as possible. There are some nice t-shirts also from Red Hat. Unfortunately, I don't have one yet. But it says containers are Linux. And this pretty much follows the philosophy. There is no big difference. We don't want it to be complicated. Certainly, if you have Docker files already, you can use them with Buildah, but this is just to explain it. Well, with Buildah unmount, we unmount the mount point from the container, the rootfs, and with commit, well, we create a new image. Et voila. However, there is one small extension we did to Docker files. One very, very common and very old, I guess it's maybe one of the first requests users had for Docker files, is we want the ability to include other Docker files, right? If not, we have a lot of boilerplate code across our Docker files. So for instance, a very common thing is installing packages. And you can group packages. There are certain groups. If you need to build a Golang tool, well, there's a certain amount of packages that you need to build them. What if there is a typo and you copied it already? Well, ideally, you should test it before. It might not be the best example. Let's just assume we need to change something. It means we have to change all Docker files, which install basically the same package. Including another one which does it and just reusing the command from there may be just more maintainable. And this is something we did. And again, containers are Linux. And something very, very ancient is the C preprocessor. So we just use that. If a Docker file ends or has the suffix .in, Buildah will run or preprocess the file, and in this case here, we have an include on a local file. So what the CPP will do is to replace the include line with the contents of the file that we're referencing. So CPP is something really old. It's something from the 70s, and you can even install it on Windows. So we're certain that this approach has a certain degree of portability. And if you want to use Docker or another tool for building this image, well, you can pre-process it by hand by just running cpp-e on the file and then using the output. So why do we have a dedicated building tool? Well, a dedicated CLI without the fear of cluttering, right? Many requests by the maintainers of Docker understandably have been denied because they said, we already have so many commands, we can't make it any more complicated. right? This is the cost of having everything in one tool. If you have a smaller use case dedicated tool that is meant to only have a reduced scope, it allows to add more flexibility, more use cases also beyond Dockerfile. It also allows for a cleaner and smaller code base due to the limited focus. We can specialize it. And a very important thing is we can have independent release cycles. It is very, very important, right? Containers evolve fast. Everything goes very, very quickly. Basically, every week there are some new news about some projects innovating, companies opening or open sourcing a new project. So this allows the project to just move faster. We are not being blocked by a feature that is related to orchestration that, in this case, Buildah doesn't care about or need to care about. Next is distributing containers. So I guess I gotta hurry a little bit. I can talk all day long about these tools. So you might imagine I can't go into the details of everything. If you want to know more or chat more, I'm happy to talk after that with you. So the tool for distributing is Skopeo. Skopeo is used in many non-Docker pipelines to distribute images, for instance, in the open build service from SUSE and OpenSUSE. There you have a very discrete building pipeline, and you don't need to start a daemon just to copy a container image from A to B. So Skopeo is really limited to copying images from A to B, from a source to a destination. It does not run as a daemon, and also like Buildah, it does not require any root privileges. And it can copy single images as well as a list of images. You might know it as a manifest list or index list, depending on which formats you're using. Talking about formats, it supports the most common and standardized image format, which is Docker version 2, schema 1, and version 2, schema 2. And certainly the specification of the Open Container Initiative, the OCI. And when you compare the binary size, Skopeo has 23 megabyte versus 210 of Docker on Fedora 31. I also added the client and containerd and other things that needs to run it. So following the metaphor of the Swiss Army knife, it's a comparatively small one. So Skopeo was born by the desire to inspect remote images. Back in the day, a colleague from Red Hat, Antonio Mordaca, he opened a pull request at Docker to do exactly this. And the Docker maintainer said, well, again, the common problem of we don't want to make our CLI even more complex than it is already, but a Docker registry is nothing than just an HTTP server, so you can even curl it. Instead of curling, Antonio sat down and implemented Skopeo to add more logic around it. So now if you want to inspect a remote image, you can do Skopeo inspect, then say you want to talk to Docker registry, and then specify the image, in this case, the latest one of Fedora. All right. So as you've seen before, there was a Docker : // This is the transport, the Docker transport that Skopeo and other tools support. Skopeo and the other tools support various kinds of so-called transports. So commonly, when we pull an image, we talk to a Docker or a container registry in general. We pull it down to the local storage. Theoretically, we could also export it to a Docker archive or a tar archive, where then the image is being exploded to. And there's various kinds of transports that Skopeo transports. Certainly the container storage, the Docker, a directory transport where it's exploding it onto a specified path. This is non-standardized, but commonly used to inspect, debug, or even you can put it on a USB drive. If you have a completely air-gapped deployment, you copy everything on your USB drive, you go into to your node, copy it there. And certainly OCI and many others. There is, when talking to a registry, there's a lot of different needs for users and customers. Sometimes you want to block users from pulling from certain or talking to certain registries. You want sometimes to disable TLS verification because you just want to debug something, or you have a test infrastructure, or you didn't set it up. Sometimes you want to mirror it. All these things you can do in the registries conf, in the containers registries conf. They're shared by all the tools that I present in this talk. Unfortunately, I don't have the time to get into it. If you're interested, look it up or look up the documentation online. It's on github.com containers image, or just do the man page, which is containers registries conf. Now I gotta hurry. Running containers. This is Podman. It's a container engine for managing containers and pods. Pods is a term inherited by Kubernetes. A pod is basically a set of containers sharing certain namespaces, maybe the network namespace, IPC namespace, PID namespace, so you can group them into some logical units for your workload. So maybe you want to put your database and your web server into one pod so they can communicate better or more easily. Podman stands for Pod Manager. And the CLI is based on the one from Docker. So when we started this tool, we were thinking about, well, is it worth investing or starting a new CLI? Well, we said, no, it's the defective one. All of us started with it, so we shouldn't change the language that we're already used to. It also allows for an easier migration. And the fastest migration is just to alias Docker and Podman. But I said enough. Now, let's go into some more details. Basically, here I want to present you some of the features that Podman has, but more traditional container engines do not. Podman, from day one, did not require a daemon and could run rootless. What it means is, as you can see here, I first do a who am I and then print out my ID. I'm not root. If I execute a container and do the same, I'm root inside. That's awesome, because my applications, which unfortunately many of them require to run or require root privileges, have those privileges inside the container, but the process running it on the host is still me, Valentin. So even assuming somebody, some attacker, some malicious attacker could take over the process, the damage is still limited by the fact of not having root privileges outside the container. Then, similar to Buildah, we can mount and unmount the rootfs of a running container. In this case here, if I run a Fedora 30 container, I have access to the rootfs. This is easier, nicer, and more flexible than using copy. Because copying into a container, if you do a Podman copy or a Docker copy, there's quite a lot of work that has to be done. If you just have access to the rootfs, in any case, you as the admin or the user who's executing it, you have full control over it. So why not just have access directly to the mount point? Another really cool feature which has been added by NTP, which is a company based in Japan, they have a lot of really great engineers in the containers ecosystem, is related to how we can manage containers, container images, and how we can look at it. So here I had 182 images on my node here. Well, this is a lot of stuff. And the local image storage can really quickly become a mess because I develop on my machine, I test on my machine, and I also use it as a user. I'm too lazy to set up virtual machines if I can just use containers. So here I somehow mix everything. But the problem is, which images does an image actually use? So if I download an image which is big, I may want to analyze why it is that big. What are the dependencies and such. And there's a really nifty feature or command called Podman image tree. So if we first pull WordPress and then PHP, and we call Podman image tree on the WordPress container image, we see that which layers this image is using. And there we see that The WordPress image is using the PHP image. The other way around, if we follow the dependencies in the other way, we can also use image tree to answer the question which layers require a certain image. So if I do it on, in this case here on Ruby, we see that the circle CI image in the very last line is based on it. One of my favorite features is container Runlabel. Container Runlabel, if we look here, we have a Docker file. Yes, I'm also using Docker files on a Fedora 30 container, and we add a label. And we call this label echo label. And so this is the key. Everything after echo label in this Dockerfile syntax is the value. And we do a Podman run on the image, and then we echo hello code mesh LDN. I build it. I run Podman container Runlabel. I specify, again, the key from the Docker file on my image, and it executes it. It might seem at the beginning like just a little playful. It's not a big thing, and I agree, it isn't, but it can solve a lot of problems because what you can specify in a container image is limited. The standards, especially the OCI, the Open Container Initiative specification, is limited. It wants to be as unopinionated as possible. And this means if we have special needs, we need to build on top of this. And using such a Runlabel, we can specify way more things. We lift the container image from specifying how it should be looking inside the container, also from how it should be executed or interpreted on or from the perspective of the container engine. If you have a look at the man page, you will see that Runlabel can execute any command on the host. Well, that's bad. And in fact, some members of the security community reached out to us and said, well, that's really, really dangerous. Our response is that it's only dangerous if you execute random container images. And if you do this, it's dangerous in any case. So this is really something for special needs if, for instance, you have one init container for a node that you pull from your trusted registry. It's not something that should be used carelessly. So you really need, we shouldn't abandon common sense for it and just execute Runlabel on some image to see if it has something or if it executes something or not. Next is Podman generate systemd. Podman has an excellent support for systemd. We can use systemd service files to execute containers. Finally, this is something that Red Hat has requested for many, many years to be able in Docker, but there it's inherently hard to do it due to the client-server model. Systemd needs control over the processes, but if you use a client for executing a container that then the server is actually executing, systemd has no clue what the process actually is. So if you do a systemctl status on a service file that follows such a model, it might display anything. It can say it's not working while the container is healthy. It can say it's working while the container already failed. Podman follows a very classical model, fork and exec. So it's very, very easy to give systemd full control over it. And still there's a few details that we need to follow, a few things we need to be careful with when we use it in systemd or when we create such a service file. So we just sat down and implemented it. So when you have a container or a pod, you do Podman generate systemd, and then you give either the ID or the name of the pod or container respectively, and Podman will spit it out. It can also generate files. So this is really, really nice. The most important part here is the third last line, PID file. So it points to a conmon PID. So when I said before that it's daemonless, and that was a little lie, but a very, very small one, and I'm going to explain why. So common, we still need some process to monitor the container, right? Because we need things like the exit code of the container. We want to monitor it. We need to clean up the namespaces, C groups, all the resources we have allocated. So we can't really get around the problem that we need some processes to monitor it, but it is not a daemon. Or in some sense, yes, but it's only managing one container and not many. But it's a really, really small one. That's why we implemented it in C, and it's really just 76K. We can also execute systemd in containers. I don't have much time left, I think. All right, 8 minutes. So you can just believe me that systemd can be executed in a container. There's certain things or certain mounts that we need to set up, tempfs that systemd needs. We need systemd to believe that it's the only systemd running on the node. So there's certain things we need to take care of, and Podman does it automatically. And it might seem like a very small thing, but when you look at, well, now I'm talking again way longer on it. When you look at how we install packages, let's say on Fedora and the services, how these services are started, especially for daemons. May it be an Apache server, may it be a database, may it be, Docker. All of these are commonly started via systemd service files. So when you want to build a container and systemd is not running in it, well, how do you start them? Well, all of us were left somehow with the fact that we have to write custom bash scripts which run these tools, somehow set up the required environments, which is very hard from the point of view of Red Hat, for instance, to support certain things, right? If a user complains about, I don't know, the Apache server not running, and it hasn't been started in a supported way, then we really have an issue here. So inside the containers, somehow regarding the absence of systemd, we were thrown back from a distributor's perspective 10 years. So for a long while, we were living in the past when dealing with installing and running our applications in containers. Same happens for Kubernetes YAML files. Podman can generate systemd service files and Kubernetes YAML files. We intended to be used, or for Podman to act as a bridge to Kubernetes and local development, right? Setting up a local cluster is very resource intensive. It is difficult. If you want to play around or develop locally, it's an easy path to migrate what you've just developed locally into a Kubernetes YAML and use it from there. It can also read it and then play it. It's called Podman Play Cube. So if you, if you want to run a certain Kubernetes YAML or service and you don't have access to a cluster, well, you can just run it now locally on the machine. Another cool feature is Podman Checkpoint and Restore. So with Podman Checkpoint, we freeze the container with CRI-O, and with Restore, and CRI-O stops it exactly at the point of execution. So if a very common example to demonstrate it is you have a loop incrementing an integer and echoing it out, so it counts 1, 2, 3, yada yada. It will stop it exactly at the point where it has been frozen, and when you restore and start the container, it will continue execution at the freeze point, which is very nice because even in the times of containers, well, we still have a host. Sometimes we gotta restart it, play in updates, but if we have a database running and there's a lot of data, well, initializing it takes a lot of time. No problem anymore. You just do checkpoint, you reboot, install the updates, you restore, and you can continue. Here in this example, I show that if you want to, you can also just checkpoint it, copy it to another server, and then remain execution there, which I find very, maybe exotic, but very cool. One other project that I want to talk about is a project I've been working on together with Divyansh Kamboy and Dan Walsh this year for Google Summer of Code. So Divyansh is the student who worked on it and did a phenomenal job. So what we were working on is to generate Seccomp profiles with Podman and eBPF. So Seccomp is a Linux security mechanism with which you can filter system calls. It's used in Android, Firefox, Chrome, everywhere, and also in the domain of containers to add one more layer in the big onion of container security that we have. But it's very tough to find out which syscalls a container needs. So commonly, there is a default Seccomp profile that Docker uses, Podman uses. And this is very loose. So we still have around 80% of attack surface that we can reduce because a common container only needs 40 to 70, but we have 300 enabled. So you can go on podman.io and read how we did it. Unfortunately, I don't have enough time to get into it. Last but not least, container orchestration. This will be fast. Here we have CRI-O. So CRI-O was born by more or less the community and also us being frustrated by having Docker running underneath Kubernetes. Again, we have this very, very big Swiss Army knife, which if new features are being added, they can have undesirable side effects, which led to a certain instability, at least over a certain amount of time, and was frustrating for the community because then the outcome was Docker has been frozen on a certain version, 1.13, and nobody wanted to migrate away anymore, which just gets or gave us headaches because you have to backport security things. So again, a very limited tool, which is CRI-O in this case. It is a Kubernetes runtime, and it's really the only use case. The only use case of CRI-O is to serve as a Kubernetes container runtime, nothing more, nothing less. Since April this year, we are part of the CNCF, the Cloud Native Computing Foundation, which is a really nice step. Made us proud because it means that the project reached a certain maturity level and trust of the community and the users. It supports, as all other tools, all kinds of container registries, all OCI container runtimes. So that's why I'm usually referring to a container engine, because based on the OCI specification for actually executing a container, there are other tools who take care of it, mostly Runc, or today there's also crun and other tools. Over 100 contributors, 90 releases, well, quite a lot of tests per pull request and collaboration across the industry. So it's not only Red Hat, there is SUSE, there's Intel, there's IBM, there's Lyft, and all kinds of other companies. So again, for building, we have Buildah. For distributing, there's Skopeo. For running, you can use Podman, and certainly for orchestration, which in my terms means Kubernetes, we have CRI-O. So it's always a trade-off. If you want to have everything on one node, you can use the big knife. But if you have non-functional requirements, security, stability, things like this, well, it might be worth considering if there are other options. All tools share the same code. They're packaged for major Linux distributions. Certainly Red Hat Enterprise Linux, Fedora, CentOS, OpenSUSE, SUSE Linux Enterprise Server, and desktop, Ubuntu, Arch Linux, Manjaro. Debian is coming soon. And if you want more information, just go on CRI-O, Buildah, or podman.io. And I promise to stop talking now. Thanks.
Thank you very much.